Hey guys, welcome back to our SAT math class. All right, so last class we looked at some word problems, right? Average, ratios, rates. This class we're going to look at some geometry concepts, okay? So geometry consists of a lot of things. So it starts out with angles and then triangles, polygons, circles, perimeters, areas, and also solid figures that are all that are three-dimensional, right? And also we're going to touch upon the coordinate geometry questions and concepts that are in relation to that. Okay, so why don't we get started and first look at some angles, all right? Let's look at some angles. The angle is what you need to know first, okay? There's different types of angles that you need to know the names of, okay? So there's first the acute angle. What is the acute angle? Acute angles are angles that are smaller than 90 degrees, okay? Smaller than 90 degrees, okay? So it can't be 90 degrees. 90 degrees is called something else. What is it called? Right angle, okay? And we show it with this symbol right here, a sort of a square symbol at the very tip of the angle, okay? All right, and then the next one you want to know is obtuse angle. You might be able to sort of guess what obtuse angles are at this point. What would it be? It's something that looks like this. So this is a slightly curved line here. But this angle right here, the angle that is larger than 90 degrees but smaller than 180, okay? This is something that you would need to remember, okay? An obtuse angle. So when an SAT question talks about obtuse angles, here's an obtuse angle in ABC, for example. And you would need to know what that means. The questions provide pictures, but the pictures are not always drawn to scale, which means that you can't look at them and say, oh, this kind of looks like an obtuse angle, so it must be over 90 degrees. You won't be able to say that because they specifically say the picture is not drawn to scale, okay? All right, so these three you would need to know. Another one that, last one but not least, is the straight angle, okay? Now the straight angle is what? It's straight, okay? So it's straight like this, and you have a dot here, and you draw the angle sign like this. So what angle is this? 290 degrees summed up together, you know? So it's going to be 180 degrees, okay? 180 degrees. That's what we call a straight angle, okay? Acute angle, smaller than 90 degrees. Right angle, 90 degrees. Obtuse angle, 90 to 180 degrees. Straight angle, 180 degrees. Simple, right? Very simple. You just need to memorize the names of the angles, okay? All right, so let's see here. The next thing that we want to know is bisection, okay? So bisection is still in the realm of angles. But all it means is that you're dividing a certain angle into two angles that have the same angle, okay? So we express the same angles in this fashion, okay? We put a line through the sort of like the curved lines that show the angle. This means that these two angles are the same, and this line has bisected this angle, okay? So you might run into a question that shows you like this, sort of a shape like that, and you say that this line is there, and this angle, A, B, C, is bisected by B, D, which means that these angles are the same, okay? So when they say things like, you know, those, like this line bisects this angle, you should be able to know that the corresponding two angles right here are going to be the same, okay? All right. Now, we're going to go over to another type of technique that you need to know, which involves triangles, okay? Triangles. But we're still talking about angles here, okay? We're still talking about angles. But this is an incredibly useful technique when you're dealing with geometry, okay? So we have a triangle here. Let's say this is angle. The angle here is A. The angle here is B. The angle here is C. Now look at this angle here, okay? This angle. What would this angle be? Now, A plus B plus C obviously would be what? The three angles in a triangle, when added together, are what? 180 degrees, right? Now, there's C here, and this straight angle is 180 degrees, right? So this angle must be A plus B, okay? A plus B. So, what you want to do is when you see a triangle like this and an extension of one of the sides, this angle on the outside is going to be the sum of these two angles that are away from the third angle, okay? So this is an incredibly useful technique to use when you're trying to figure out angles within a shape that's given in the question, okay? So you don't have to go through the whole process of, okay, let's get this angle first, and then let's get this angle by subtracting this angle from 180 degrees. Okay? So that is something that you need to know in order to do geometry questions in an efficient manner. Okay? All right. Now, next part that we have to cover are special triangles. Okay? Special triangles, I mean, are very sort of simple because they are given in the test booklet that you guys receive. In front of the whole test, they give you angles and the ratio of the length of sides of each of the special triangles. You're able to use that, but I would advise you to know which special triangles have which ratios of lengths before you actually go into the testing area and take the test. Okay, so there are made in sort of like two special triangles that you would need to know. The first one is this, where the angles are 90 degrees here, 45 degrees here on each side, okay? Now, so in this case, what would the ratio of the lines be, the sides? That would be 1, 1, root 2. Okay? This is one triangle that you need to remember the special sort of characteristics of for this specific triangle. Okay? And then the second triangle that you need to know is this, the one with 30 degrees. Okay? This actually is a triangle that is used a lot in physics because it gives a very convenient ratio for each of the sides. And that is 2 to 1 to root 3. Okay? 2 to 1 to root 3. So, for example then, if this length was 2 root 3, what would this length be? Would it still be 2? We're talking about ratios here, right? So if we're actually putting in an actual length for one of these sides, the other side will actually change its length according to the ratio between these two, which is 2 to root 3, right? So in this case, it would be what? This is 2 times this, so this should be 2 times this, which is 4, okay? Does that make sense? This is how you would use the line ratios when you're using special triangles. Okay? All right. Now, let's see. So another thing that you would need to know is something called, we're looking at geometry, sort of different types of shapes here. Okay? And the next thing you need to know is something called an isosceles triangle. Okay? Now, the isosceles triangle is a triangle that has two sides that have the same length. Okay? So I'm going to mark it like this to show that these two lines are the same length. Okay? Now, a sort of a property that comes with this is the bottom two angles here turn out to be the same. Okay? So A if this is A, then this has to be A as well. Okay? This is what we call an isosceles triangle. Okay? Now that's going to come up a lot in the SAT math section, the geometry section. So it's very important to remember just this name and what it implies, which is that two lines of a triangle are the same length. And then the bottom two angles are the same as well. Okay? All right. The next triangle that we want to look at is the equilateral equilateral triangle. This is something that you definitely have to memorize the name of and know what it's about. This is a triangle that has three sides the same length. Okay? So, in this case, what would one of the angles be? They are going to be 60 degrees, okay? 60 degrees. Okay? So, equilateral triangle, three sides the same, all angles are 60 degrees, okay? That's all you need to remember, all right? Very good. Now, the next thing that we want to look at is the Pythagorean theorem, okay? Now, this is applicable to all types of right triangles, okay? So it can be, it can look like this, and this could be the right angle. It could be like this, okay? All different types of triangles that have a right angle, you're able to apply the Pythagorean theorem, okay? Now, how does this work? All you need to know is this. Let's draw a sample right triangle and label the lengths of the lines as A, B, and C. Now, most of you would already know this, but we'll just review it. A squared plus B squared is equal to C squared. Okay? This is the relationship between the three lengths that you will see in a right triangle. Okay? And this is what we call the Pythagorean theorem. Okay? And this will be used a lot in the SAT math section for geometry. So it is very essential that you memorize this relationship.